Good afternoon. It's good to have everyone back and to our afternoon session where we're going to kick off with good ongoing work and in the continent with contributed papers. We have a series of 3 papers and we're going to start with Tesfay, who is going to present to us a student counseling chatbot. Welcome, Tesfay.
Okay, welcome everyone. Thank you. I think I have to share the video. Okay. Can you hear me?
Loud and clear.
Yeah. Perfect. Okay. So let me share the slides. Is that shareable or?
Yeah, you should be able to share your screen.
Yeah, okay.
We still can't see your screen. That's fine. Yeah, it's coming up. Yeah, we can see it.
Okay. Thank you, everyone. This is Tesfay Gebremeskel. I am from Ethiopia, Makerere University, Makerere Institute of Technology, and my paper for today's presentation is AI towards counseling, student counseling using chatbot. So thank you for following me all over the world, in particular in Africa, Kampala. So I think due to COVID, we are unable to get each other. So let me start with outlines. The first one was introduction and what is counseling, the objectives of the paper, scope and limitations of the study. We have also methodology and some architectural design, prototype, and we have also evaluation and discussion of the results, then conclusion. At last, we will have some references. So as introduction, it is due to the advent, the internet provides a significant platform from which people can explore and develop their career thinking, learning and development. So we are in a way that the world is making, coming into what? Okay. So, sorry. So these all things, in education, in agriculture, almost in everything, internet is there. So let's think about counseling and mental health with incorporating ICT infrastructure. So what is counseling? As you can imagine the picture that one cannot decide in. There are many ways, but the difficult thing is in which way you are following or which way is better for you. So it's very difficult to decide. Sometimes all of us can get such problems. So people by nature have their own role models to follow, or some people to guide them. They need some people to guide them. So counseling is the nature in which you can guide people, you can counsel people, in which when they are in a series of problems. So when we come to counseling, the thing is, where can we get the adults and the users? So it is definitely in schools. In schools, childs are there and adults, young people can be found in schools. So school-based counseling is a professional activity delivered by qualified uh, teachers or professionals in schools, universities, or institutions. Okay, so those are, I think, people can get themselves in stress. It might be due to financial problem, it might be due to anything, but with high painful or due to some illness, they they go to serious mental illness. Counselors offer travel and or distressed children and young people an opportunity to explore and understand their difficulties within a relationship of agreed confidentiality. That is, we need counselors that they have to keep our confidential rights, and the confidentiality is very serious here. Okay. So effective counseling must aid in improving self-protection, people, and enable achievements of life tasks. Counseling should be empower users to contribute fully in profit from the social and economic development of the society. Okay, so if we really use the importance of the counseling, so we can profit whether it's socially or economically within a nation. Okay, so the internet and its interconnected web resource has taken guidance and counseling service beyond the face-to-face method of rendering service to electronic based counseling. So this the internet and its interconnected web resource, so we have a resource in we mean the resource is there, but the difficulty is how can we use the resource and wise use of resources in the globe. So why counseling? But I think we have seen many things about counseling, but data from the WHO mortality database indicates that 85% of the world's suicide occur in low and middle income countries. This suicide is the result, outcome, or the product of mental illness or due to some low counseling activities. Okay, if we use those mental illness within time, or simply if we know what the problem is, whatever happens today or yesterday, we can mitigate the problem what will come tomorrow and the day after tomorrow. Okay, so those 85% of world suicide occur in low middle income countries, which may probably be in Africa. Okay, in some Asian and Africa low middle income countries, especially sub-Saharan countries, will increase due to some unavailable human resource to administer to counsel of those problems. Each year, the World Health Organization (WHO) estimates that almost 1 million people die from suicide worldwide. Okay, so as I told you, as I mentioned earlier, suicide, it might be suicide, it might be selflessness, or anything is occurred due to lack of guidance and counseling services availability. Okay, so when we come to our students, when why we are focusing on student, the large number of population either in the world or in Africa, Ethiopia, or in our universities and schools are users. Okay, we can get some mass population. If we do a miracle on counseling services or guidance services, we can easily mitigate what is happening, the effect due to either suicide or any other mental illness. So let's see here. We have the global by age, by country income level. let's focus first in the age. So 15 up to 45 is the highest level. Okay, the highest level suicide is committed in 15 up to 45. So in number, in high income countries is lower than the low income countries. This is the data taken from WHO that is reported by 2016. Okay. So what are the opportunities here? We have the problem listed above. Then, well, do we have opportunities whether to mitigate or to eliminate such problems? Then, by considering interval 15 to 35, most of the time, especially by taking a sample from Makerere University, that is 15, that is not 15 actually, but 18 to 30 is all university students from the first year to graduating class. Because we have some graduating class of medical students, that is 6 years to take. Then the advantage here is mass availability. The students are there, so we can guide the students or the resource easily, whether by having more counselors on that area or installing the counselors there on the universities in each with the standards of the WHO. The other thing is diversity. In universities, as we know, many students from different locations will be available at a time in a single place, okay? The other thing is easy to reach. That is the availability. We can, they are available there, so we can reach them easily at once, okay? Easily at once, we can reach them. The other thing, but we said easy to reach, but how to reach, okay? ICT needs to be combined with the traditional way to improve efficiency. If we take the traditional way, that is face-to-face counseling, the face-to-face counseling, one counselor can, for example, can be counseled for more than 5 students at a time within a given time. But assume we have, it's not assume, but real data we have, for example, in Makerere University, 32,000 students. So for those 32,000 students, there are only, there is no longer, there is no more 5 counselors. So that is one for one counselor for more than 1,000, okay, for more than 1,000, almost 1,000 will be. That is very inefficient, okay? That's very inefficient. So we have to install this the traditional way to improve efficiency with some ICT infrastructure. But many counselors and students are unaware of having a little knowledge about the use and the integration of ICT in counseling. The existence of ICT in the cooperative educational environment can help to improve thinking ability and make classroom environment for educational growth. So we have some assumptions here. The assumptions are the research is based on the preliminary assumptions that poor academic and social upbringing of students attributable to lack of counseling and guidance service and inability to probe into students' life situation, okay? So what are the challenges with ICT infrastructure, even with taking ICT infrastructure with counseling? So there are, it's not fully solved. A little bit, you can reach some people, but it's there is still a problem. What's the problem with the current solution with the help of ICT is, the first one is lack of human resource too. For example, if we use ICT infrastructure for video conferencing, for for video conferencing, even we can have guidance and counseling service with video, with chat. Still there is there is availability of a human resource. The counselor should be available, and that is costly. For example, there are many websites, there are many sources that are either online or in person. That is, as you see, $40 to $70 per week for a session. Okay, then you have to, if you are if you want to get counseling service, then you have to pay such amount of dollar per week. In person, that is 50 to 150 per session. So we are here in low income countries. So how can we afford them? This is a real problem also. And the availability, even there may not be available at any time. Okay, at any time. For example, if someone is at risk when in the midnight, but the session is already terminated, so he cannot get any service at that time. That is availability. The other thing is the privacy. This is the main issue that we got from the data resource. The privacy is the main issue in students. Okay, so students are not interested to tell everything for the counselor. This is the main issue. Either the counselor is using ICT infrastructure or in-person, face-to-face counseling. There are many people, or especially in this case, the students are not willing to tell everything what they are feeling, what's there on their mind. So it is very difficult. The privacy issue. They are not going to trust because it might lead for some unnecessary things in their life, in their next life. Okay, so there are solutions for this too. Let's support it with AI and deploy in cloud so that everyone will have an access in the information and get service anytime, anywhere. Okay, so for this solution, let's host a chatbot. Let's host a chatbot. Then this chatbot or the conversational agent will give a service for either students or anyone that that on time or on demand. So this conversational agent always asks, let's talk anytime, anywhere. Okay, this is hello anytime. This is hello anytime. That's let's talk anytime. So let's introduce that is it's because chatbot, if you don't support chatbot with AI, that is not almost it is almost manual. Okay, it's almost manual. So there are some AI classes with machine learning, expert systems, natural language processing, speech recognition, and planning, robotics, also computer vision. I think that we have on different papers, we have seen all of them. Then inside each category, there are sub categories too. Then it's broad, that AI in general is a broad concept, but less limit to NLP with natural language processing. Is a manipulation or understanding text speech by any software or a machine. That is the NLP. An analogy that humans interact, understand each other, views, and respond the appropriate answer. If you talk some English word or any other human language, then the computer must answer by understanding the human language exactly the same as another human can answer or can replay on which it is asked. Okay, so generally, what is the objective of the study? It is the research to design a student counseling chatbot in English and in Amharic, that is the local language for students. We are not sure that there is no one is capable of Amharic in language in universities, but but let's support in both languages. We can even go through many other languages after successfully host the chatbot to each university. but English and Amharic are enough for at this time. Okay, the English is an international language, Amharic is a national language. So if we use those things, and if it is somehow productive on those languages, and we can see and host the other languages, because the tool that we are using to implement the project or the system is language independent. So what are the specific objectives? There are some specific objectives too, to find out the extent to which counselors and students know and use intelligent counseling technologies. What are the counseling technologies? Who is there are counselors and there are counseling, or one who wants to be counseled, or who wants access for a counseling service. So what is the extent, to what extent does they know about intelligent counseling technologies? The other thing, design the general architecture of student chatbot. So there is, we have also a general architecture, design an algorithm, local language data pre-processing. Okay, so there are some algorithms that are pre-processing for English language, but that is very difficult for local languages are not available. So we develop an algorithm. Also develop the prototype of intelligent student chatbot. Okay, the intelligent student chatbot. The other thing is, finally, we classify the text, the chatting text, to risky or non-risky. In this case, we already use the communication channel is smooth, and that can hold either the text is very risky or it's not risky. So if it is risky, then the student is suspected to maybe to mitigate such, for example, for suicide, or cases of suicide, or cases what makes them such problems. Okay. So what is the scope in this paper? The scope for this paper is to design and implement the prototype, okay, the prototype for the counseling and guidance domain, in particularly university students. So in this case, this is for the time being in Makerere University, or in Makerere Institute of Technology. But there is no way that the system is not going to, for all, especially for African countries, okay, for African universities. So there are some limitations on this. The first one is the data set created, the dummy data, especially for Amharic text classifications. For the classifications purpose, we use the dummy data set, whether it is silly, risky or not. We use some manual pre-processed data dictionary. Okay. The other thing is the chatbot does not support Google Search API for response accuracy. In some cases, when the chatbot is unable to respond with the correct answer, or if the real answer is there on the chatbot's brain, so it's lack of Googling, or it's lack of supporting from any other sources like Google search or any other search engines. This is as taken as a limitation. So what is the research methodology? Then the research methodology for this paper is design science research methodology approach. Okay, so we have an environment, the relevance, then the information science research. So the rigor, that is the applicable knowledge environment. Also we have a knowledge base. Okay, in this case, we have in the environment, which is people taken as students and organizations that are going to use the system, will be universities, schools, and other institutions. Technology, which is an application. So on the relevance, that is the business needs. Okay, so develop method information science research. So the counseling chatbot design is for assessing and justify using experimental and self-evaluation. then that is the refine will, the system will be refined. Then later, additional knowledge to the environment, to the knowledge base will be added. For example, here, there are, when the students interact with the system, we can easily track what the students or what any other service users are in need of. Okay, for the future, we are just tracking the texts or the messages, what they exactly need. Okay, then we can easily make the system efficient and productive. Okay, in this case, we have methods and models, the methodologies that analyze and the process model. Okay, in the we have in the knowledge base. So we use some implementation tools, that is the Python as programming language and Jupyter Notebook for web framework, and NLTK, NLP package for natural language processing, and to pre-process some dummy and processed data, and scikit-learn library for text classification. We use somehow this is I actually at last, but we use scikit-learn libraries, and we will as SVM for classifications. And the other thing, Chatterbot Python dialog engine library. This the dialog engine is the Chatterbot. So those are the implementation tools for the research. So what is the existing framework? We can chatbot conversational agents framework. The first one with the conversational domain and the generative based or the response domain. Okay, the response generation. So we have open domain and closed domain. Most of the time, closed domain are within a single domain. Then we will use the texts or the data set within for that domain only. Okay, for that interval of data set. And open domain for everything, that is we can use the system for everything. So we have the response generation methods. The first one is rule based, that is in most of the time we will use the if else systems. The retrieval based, we will have retrieval based, the carpet based response generation, and the other thing is the generative based. Okay, the generative based. So when closed domain with rule based, that is simple dialog tree. Okay, the simple dialog tree. If something is this, then replay with this. That is only the simple dialog tree. The other thing is retrieval based with closed domain, that is machine learning based on the machine learning. We will have, so there are some searching algorithms in the machine learning there, and some classification algorithms too. The other thing, generative based closed domain, that is smart machine. Okay, that is very intelligent and smart machine. The other thing is open domain with rule based, that is totally impossible. Okay, and related retrieval, that is carpet based with open domain, is impossible too. Then generative with open domain is an artificial intelligence in the support of with the big data. Most of the time, open domain is categorized as the big data. So generalized architecture design. Okay, I think that's visible for everyone. Okay, so let me clarify here with the general proposed architecture, the chatbot architecture. So we have AI, ML, or artificial intelligence markup language data processing. As far as we use AI, ML data, then we have noisy removal, tokenization, normalization, and stopwords removal. Then this is totally a pre-processing. Okay, the pre-processing, the data is pre-processed here, then it's ready for training. Then after training, it will be stored in the bot brain. will have both brain, then it will store in the both brain. The other, this is for the first language, that is the international English language. Okay, then the second one is for Amharic local conversation dataset, which is from Telegram and from Facebook, but mostly Telegram. Then noisy removal for such there are, because the data is downloaded via manual process, then there is no, we didn't use any API for Telegram to download the data set. Then we have to remove some HTML and XML files, photos, and any other something symbols that are not actually text. So we also use tokenization. We have to tokenize each sentence. Then we use normalization too. Then English word Amharic meaning text ready. Okay. So we have we collect information for other dictionary, then the English word Amharic meaning text ready. Then pre-processing, data pre-processing is here. Then language translation will be on this, okay? The language has to be translated from English, from Amharic to English. Then that has to be trained. That has to be trained, then it will store to the brain, okay? To the both brain. Then once you end up with a training from both from Amharic and English, then the bot is ready to, the bot starts conversation with welcome message, okay? Then welcome message conversation will be ready for any user or service user. Bot asks a user language tool after welcome message, then it will be asked for either English or Amharic. Then conversation will be started here. In each conversation, then it will store, the bot brain will store each user's input for four-letter use, okay? Then in this, the manual dataset will also, we can, without any training, we can use the manual dataset to train or to answer for users' information. Then the other thing is chat text categorization, that is the chat text classification. While conversation, we have to categorize or classify either the text is risky or not, okay? Either the text is risky or not, we have to use such text categorization. Then the data is stored in database for future analysis. This is that we are ready to, for the data set will be ready for next conversational agents or any other things, especially for decision making, okay? So we have process model that is within the conversational agent, that is user input, pre-processors. We have in the pre-processors language selector, ASCII converter, Unscape HTML and XML, okay? Then white space removal. All those will be in the available in the Chatbot dialog engine, okay? So after pre-process, the base match, so logic, there are logic adapters. For example, two list of them. The first one is base match, time logic, mathematical evaluation, and specific response. Okay, so the best match will select the best relative answer to the generate to the generate response. Then time logic will with time. When a user asks for time, it might be this is not actually included in the Amharic, but it's included in English. That is, when you are asked what time is it or what, then the system will give you with serious questions, with a series of the response of the time. Then the other thing is specific response. For specific reasons, the system will give you a specific response, okay? Then the generative response will give you, will give the user or for the GUI or the interface with highest confidence level. So all the best match will give a response, time logic will give a response, mathematical evaluation will give a response with mathematical evaluations. If someone is asked to add two numbers, then the response we have to just add the numbers, then give a response. The specific time will give a response. So the generative response will give the highest confidence value. So every logic adapters have will return the response with the confidence, with some confidence values. So the highest will be returned, okay, to the user. So that is in the flow diagram. Bot starts the conversation. The user reply with question or answer after the bot is just started the conversation. So system checks the conversation in the knowledge base. So if the system means it's a chatbot, okay. So if there is no, they register to the database for training, okay, for training in this case, saves for training, okay. Then generate default response. If there is a default response, it will generate a default response with the value. Generate valid response. If there is if the conversation is in the knowledge base, it will generate response, valid response based on based on we have the confidence value here. So based on their confidence value, it will respond to the user. So response will be given to the user. So end of file is that end of file means is the user is also asking or wants to terminate the conversation. So continue chatting, then the user asks a question or will have some chat texts with the bot, then it will continue like this. But if the user is just terminates, the end conversation will be end. So prototype for the user interface, this is hello, welcome to our guidance room. So the student will have its own message, okay, will have its own message, then it will replay the same. So here we have the user evaluation of the framework. The first one, do you think the proposed framework is sufficient? So we have 8 or 5 of 2 of 4 and 3 of no, 2 no and 1 no. So totally we have 48, the total of 48, then that is 96% of average is agreed to that the framework is sufficient, okay? So such things have been asked to users with the questions: do you expect the framework is reliable? Can any researcher use the framework easily? So can the framework represents the how the modules of the framework will integrate to each other early, and can proposed framework will guide easily for prototypical implementation of the proposed framework. So all those questions are evaluated. So total of 94.8% is evaluated, okay. So on the prototype, 9 of serious questions have been asked to the users, then 95% of an average of 95% is agreed that the system is most evaluated, okay. Based on that, we just give sufficient information to the university too. So let's comparative analysis of the results. The research, we have analysis based on users. So comparative analysis of the result with other researchers. So there is Lacuna, Abbas, and in 2020, in 2010, that is improving chatbot chatter learning interface entity. The problem is solved here. So tools and techniques used, one match and all match categories for keyword matching with built-in AI ML chatbot only. Okay. So learning ability is yes. The research direction, open domain with Carpus database. So it was really closed domain, but for research, for future research direction, that they recommend open domain with a Carpus dataset. The other engaging high school students using chatbots by using tools and techniques, pattern effect pair algorithms, then the learning ability is unknown. It's not actually, there is no research direction to. The other thing, question type, we solve it rule-based approach, that is pattern matching only. Learning ability, no. The next research direction, why, how question types are presented there. The other thing, Satu and Hasnat 2015 solved a problem, integrated application of chatbot, that is AI ML based backend with chatbots. So learning ability is yes. Then the multilingual and grammar checker for future direction is just. The other thing, Windows to 2016, the question and answer system with the closed domain approach have been solved. Then the tools and techniques used were pattern crafted for legal documents only, and there is no learning here. Open domain Amharic question and answer is for its research direction, future research direction. So Andrew J. and Freo integrating chatbot with a GIS system in 2018 solved a problem with a chatbot using the GIS systems, and uses a technique, the framework, RevScript framework and AIML. There is no learning here. Chatbot has speech recognition. Okay, for future direction is the chatbot should have speech recognition. And this paper, intelligent counseling for university students, Python chatbot AIML, and there is learning ability, and spell checker, voice, text, and multilingual word name will be for future research direction. So discussions of the result based on the prototype. We have prepared totally 100 conversation for text classification purpose only. Okay, this is to check whether the system classifies correctly or not. We have tried to classify the question type using 3 algorithms in MB, and that is, it's not 3 but 2. That is MNB and SVM. Okay, so from those classifiers, SVM, that is support vector machine, were performed well from the question type classification with 60% to 17% accuracy. That is 65. The problem with the interval here is the data is not actually well prepared for conversation, especially in the Amharic language classification. Okay, so that is the lack of data is the main problem with this. Due to performing well, we choose SVM classifier to the part of the study in the text classifier. I think I didn't include the main bias classifier with 60 to 65%. That is 60 to 65% well performed in this. So as a conclusion, we aim for the research to provide new method of guidance and counseling for university students. Okay, so the purpose is to provide with new new method or approach to counsel students. The chatbot was created with the latest technologies and libraries, which is being used widely in many areas. For example, in the area chatbot is using in bank systems, okay, in business areas, is in most of the time is a chatbot, okay, that whether its model is different, but many ways are coming with the chatbot these days. Clearly indicated by the discussion is building a chatbot is the best and modern way of interacting with machines and robots to create stable and industry standard. Okay, so as we have seen earlier, many things are will be solved, especially with the counseling purpose. They maintain privacy. No one is afraid of giving his information. Okay, there is a lot of potential in the artifact if taken forward in the future to develop more advanced version. the artifact will make difference in students' lives. Okay, so if we make our purpose is one and one, that is maintain students' life. We should maintain the students' life and the students' future career. Okay, so to maintain such things, we have to use the potential. We have to use every potential that is available in the globe. Okay. As a conclusion, again, the findings underscore the need for school-based mental health promoting programs that enhance young people's self-esteem, reduce psychological distress, and boost subjective well-being. Okay, so as reference, we have seen World Report on Violence and Health, exploring Australian response in 2002, World Health Report 2004 and 2016 too, suicidal statistics and facts, suicide awareness, voices of education, published on 2019. So those are I think this time is COVID pandemic, global pandemic. So everyone should keep himself. So thank you very much. Thank you for hearing. If you have any question for discussion.
Yeah, thank you very much. That was a very good walkthrough through the NLP WIC pipeline. Thank you very much for a good talk. It's now time for questions. Yeah, yeah, yeah. Yeah. There was one question on the chat.
Okay.
Yeah. Whether there was a good one of the advantages of face-to-face counseling is the conveyance of human emotions, and that's a thing that you might be relatively impossible in a chat box. How do you intend to address this?
Yeah, of course. Nowadays, AI is working on such areas. The emotions of human intelligence is on the process, but in this case, it's impossible to imitate such feelings. But in the future, I think AI is towards that area. Then everyone will actually have an answer for such questions after AI is resolved with this. But in this case, it's not, we are not just removing the face-to-face counseling. Just we are combining face-to-face counseling with ICT infrastructure, AI technologies, until AI is fully covered all the necessity and importance of face-to-face counseling services. Okay. So I mean it. At this time, we are not removing the face-to-face counseling, but just we are making it easier. While if someone is, for example, during the chatting, if someone is risky, categorized its text as risky, the students what is the problem will be identified and decision will be taken by especially by the institution or by the university. Okay, so at last face-to-face counseling is must. Okay.
Mm-hmm. Okay, but and like another one, the last one, which combines actually two, that how do you control the emotions for that the connection between the counselor and the student who needs help does not break, or whether it doesn't grow deeper? And like in a wrap, in a and in a combined way, we can say that does automation, an automatic system, actually give a wrong advice to a student? Can that such a case occur?
Of course, the system will give an advice that is optimal for everyone. I think we don't have to forget that there are standards even not only for machine but for face-to-face counseling, either for professionals, for counselor professionals have their own standards. Okay, so such standards are going to be hosted to the system too. And if someone is that's why we just categorized the texts in the first place. If someone is I hate myself, if says I hate myself, or I am selfless, or I am meaningless for this world, so he is, I think, going to commit, he may be going to commit or a suicide. So we have to prove, we will reach before he is doing some actions. Okay, so the system is helping us to decrease, not actually to totally eliminate everything. So
And,
those systems will help. Yeah. Okay.
yeah, okay. Okay. And how are you going to handle people, students with disabilities, say those who have sight problem or or cannot
Yeah.
type text? How do you does your system take into consideration students with a
Yeah.
disability?
Yeah, of course. Our consideration is not included with what you said. Actually, for disabilities and for especially illiterate peoples, those who can't write or those who can't do anything with conversation, is not a solution. This, but I hope in our future we have to consider these issues too. Okay, even though even though a system is unable to solve such things, but we recommend this system, and we also appreciate the next the next issues to consider and make the system efficient. But I don't think whatever the system is, they will respect. I don't think they will they will replace human beings. Okay, but they can somehow mitigate our issues. I think there are two questions too. Can I read?
Yeah, sorry, I was muted. Those are the questions which are asking about the disability. How will you handle students with disability?
Okay, I think for the second question, problem with text. So in the future, we put in the future work as a research direction in multilingual text to voice to text. Okay, voice to text conversation. That is in our future research direction. We have considered these things.
Okay, all right. Thanks. Thank you, Tesfay. Our next presenter, we are running behind time, so we'll give you a maximum of 10 minutes. Beston on Internet of Things based mobile application for environmental condition monitoring in poultry house with machine learning algorithms. That they'll be presenting back to back after he finishes. Adebayo Segun will present on AI extension using AI UAV for local farmers. So they will present back to back, maximum of 10 minutes each. Thanks. You're welcome. Are you there? Beston, are you ready, or we get
Yes, I'm ready.
Yeah, can you start presenting? Yeah.
Okay.
You have a maximum of 10 minutes, and then we'll have Segun back to back, and then we'll take questions for both presentations after both of you are finished. Yeah.
Okay, thank you. Good afternoon, all. My name is Beston Lufyagila, a master's student in Information and Communication Science and Engineering from Nelson Mandela African Institute of Science and Technology in Arusha, Tanzania. I'm here to participate in this Data Science Africa workshop to present my paper titled the Internet of Things Based Mobile Application for Environmental Conditions Monitoring in Poultry House with machine learning algorithms. So in this presentation, I will take you through introduction, problem statement up to conclusion. In Tanzania, livestock sector contributes 18% of agricultural GDP and 4.7% of the national GDP. However, chicken accounts for 86% of animal kept by families in Tanzania. And out of 4.6 million animal keeping families, 48% just farm chicken for food and source of earnings. This is according to a study conducted by Gebremeskel and its collaborators. And also another study conducted by Astil and its collaborators shows that the global demand for chicken meat and eggs will be more than 40% by year 2050. However, in order to maximize the productivity of this poultry sector, first of all, this sector is actually affected by environmental conditions such as temperature, humidity, and ammonia gas. Generally, according to studies, the temperature for growth of chicken is recommended to be around 20 to 26 centigrade, whereby above it, chicken suffer from the heat stress that hinders even the process of taking food. And when the temperature is below 20, that is below recommended one, chicken actually takes more food in order to compensate to generate the internal heat, which is actually costful to the farmer. And at this time now, chicken do not produce well or do not grow well. Also, the recommended humidity is to be around 50 and 70% for the normal growth and the productivity. But also ammonia, this is the gas which is present in a poultry house, and it is actually produced when the microorganisms found in the droppings decompose that droppings into the uric acid. So when they decompose the uric acid found in the dropping, they produce this ammonia gas. And this ammonia gas is very harmful to the chicken simply because it damages the respiratory systems and as well as causes lesions in the cornea of eyes. And the standard ammonia concentration need to be 10 parts per million, should not exceed 10 parts per million. However, this is a very small amount of concentration, whereby the normal human being cannot detect it. Human being starts to detect it when it is 25 ppm. So this is one of the chicken that has been affected by ammonia. So you can find there are lesions in the cornea of the there are lesions in the cornea of the eyes. So generally, the problem statement now is currently farmers in Tanzania, they use charcoal stoves, kerosene lamps, and as well as opening or closing windows to control this temperature and humidity as well as ammonia. And some of them are using the commercial off-the-shelf monitoring systems such as hygrometer and thermometer. But those instruments are expensive and they operate manually because the farmer has to visit physically the poultry house in order to read the temperature and the humidity as well as ammonia for that particular day. So you can find this is one of the charcoal stoves based on the studies we have conducted. This is one of the charcoal stoves that is used by the farmer to regulate the internal temperature of the chicken. So this method still results into low productivity and reliable, producing accurate results and are expensive, but also results into low productivity of the chicken and eggs. Also, there is a persistent occurrence of diseases such as Salmonella, Newcastle, and Coccidiasis, simply because these are viral diseases, and for those viruses to operate, to grow or to reproduce, needs certain conditions of temperature, humidity, and oxygen. So when they have favorable conditions, which supports them to grow, they really grow and affect the poultry. So that's why we have decided now to build an IoT-powered mobile application with machine learning algorithms to aid farmers in decision making. And this is the methodology we are going to go through in order to implement the system. So far, we have actually implemented this part, and we have deployed where we are now collecting the data. But our future work is now to plan on how we can now take this data, because the issue is not actually only monitoring. Maybe it's not only for the farmer to monitor the conditions in the poultry house as well as to control. But what can we do further with this data now? Where we are planning now to use machine learning algorithms so that they will be predicting and giving suggestions in form of decision, suggestions to the poultry farmer. But currently this farmer can control the conditions in the poultry house through their mobile phone. But that is not enough because we are collecting this data. What can we do with this data? So those machine learning algorithms, it means from here now, machine learning algorithms, what we'll be doing is to predict a disease that is likely to occur. We know that, for instance, the viral, the Coccidiasis disease, the favorable conditions for the bacteria, for the virus to grow is actually, the temperature is 21 centigrade up to 32 centigrade. But also the relative humidity
you have
is around
3 minutes.
Thank you.
Yeah.
Is around 20 centigrade. So by using these parameters, we can predict that coccidiasis is likely to occur and give suggestions on the best vaccination that the farmer can give before the incidents prevail. But also based on the trend of the ammonia, we can give suggestions on doing cleanliness of the poultry house. So far we have actually, this is the hardware that we have already implemented and deployed it to the site. And this is the control panel where we are, we monitor those information. And these are the sample data we have collected, and we continue collecting them so that we can use it for analysis. Thank you.
Yeah, thank you very much, Beston. And next is Segun. You are welcome. Yeah. Please feel free to type in the questions from the previous presenter as the current one is presenting. They will all be answered after Segun finishes. Yeah, welcome, Segun.
Okay, thank you. I'm trying to share my screen. Sorry, I'm trying to.
Beston, remove your screen. Can you stop sharing your screen so that, yeah. Beston.
Yeah, okay, sorry. Sorry, I'm still having issue trying to. Okay.
Are you having issues sharing your screen, Segun? I can't.
Should give you the opportunity to share. Joyce, can you give me the opportunity to share the screen? Dina? Hello, are you there?
Yeah, I'm here.
Yes, you can share
Are
your screen.
you, is
Yeah,
disabled? Okay, yeah, it's shared now.
Yeah.
Wait. Yes. Maybe close it. Share again. No, share. Okay. All right. Okay. Can you see my screen now?
Yes, it's okay.
Sorry for the delay. Thank you very much for giving me the opportunity to present this topic. It's artificial intelligence extension unmanned area vehicle for local farmers. With me on this research is Hallelujah Aworinde, Akinwumi, Akinwale, and Adebayo Ayantiji. Now, these are the team members. It's cut across several fields of computer science, engineering, and agriculture. We want to thank Bowen University, which is the funding organization for this research. So Bowen University is an institution in Nigeria, Osho State to be specific, and they are behind funding this research. To start with, I want to start by looking at what Ban Ki-moon et al. In July 2020 says that there's a need to bridge African data gap to strengthen food, health, and economic security and overcome a predicted continent-wide recession. So his opinion is that there's a need to invest in digital agriculture, and investing in digital agriculture can help Africa. Now, if we look at a statistic by Food and Agriculture Organization, FAO, it has predicted that the world population will reach 8 billion by 2025 and 9.6 billion by 2050. With half of this number concentrated, if we look at the image there, half of this number will be concentrated in Africa. So there's a need for us to improve our food production. And one way of doing that is employing technology, employing ICT in improving our agriculture produce. Another motivation is also from the Food and Agriculture Organization, showing that seeing a crop from the air can reveal pattern that expose many things. And some of these things include irrigation problem to the soil, soil variation, and even pests and diseases. So viewing it from the air, some of these things will be seen beforehand and tackled so that farmers can use this data from satellite drones and use it to improve their yield, use it to improve the way they apply fertilizer, use it to improve water or chemicals which they applied on this field, and by that save time and improve their yield. Now, several work had been going on, several work had been done. If we look at from the figure, Sky Spec is using drones to monitor or to identify abnormalities for wind farms. Now, when a wind farm has monitor that is running harder than they should, they use drones and to help monitor humidity, weather condition, to be able to quickly detect if some of this motor or wind farm is defective or problem is due to arise. So some of these drones are used to monitor that. CAPE is also playing a vital role for mining companies using CAPE area telepresence by providing volumetric mapping that help them measure their stockpile. Now, with high resolution imagery fed into an image processing pipeline, the accuracy of access measurement can improve, can be improved, and it's been improved. So these are some of, and there are other works that are also going on using drones to monitor several things. Now, the aim or the objective of this research is to bridge the gap between the current and desired capability of agricultural output by developing an adaptable smart farm solution for Nigerian local farmers. And the team is trying to do this through the development of autonomous unmanned area vehicle. This autonomous area vehicle will be capable of scouting cultivated fields while collecting data. Now, the data will be connected with data analytic pipeline. So the team will be building data analytics systems for diseases and pest detection, yield, estimation, forecasting, maturity monitoring, crop abnormalities detection, and several other things. Now, this is an ongoing research which we've embarked on. We are still developing some of the systems which needs to be done for local farmers. We'll also be liaising with local farmers, mostly farmers in Nigeria put themselves in groups. We call it cooperative groups. So we'll be liaising with some of the cooperative groups to test some of this system, providing these services for them and monitor their yield at the end of the farming season. So this will help in determining social and cultural influences of smart farming. Now, this is our conceptual framework where we'll have drones doing the observation on the farm field. It will be autonomous, scouting the farm field, checking for abnormalities on the farm field, reporting some of these abnormalities to the cloud for actions to be taken, whereas also taking some other decisions that could be taken by the drone. We'll have diagnostic cloud services to take this data and perform machine learning analysis on them to see if there's abnormalities in the data gathered. And some of these decisions will be related back to the farmers using their mobile app. So we'll be looking at developing mobile apps for farmers to be able to get some of this information and make the necessary changes they need to make on their farm so that they can improve or keep their yield at optimum. We expect that this research will contribute to knowledge in several ways, such as research, the design and implementation of the hardware, software, and behavioral patterns of an autonomous unmanned aerial vehicle will boost innovation and knowledge exchange. The need for cereal crops will be better understood by analyzing imagery data captured from the sky by autonomous system. Now, we believe that this will also enhance teaching of some of these technologies, such as Internet of Things, big data analytic, smart sensors, ICT, and so other things. We'll also be providing community service to the areas which Bowen is situated, to farmers in these areas in trying to improve their yield and making their life better. Now, the research had started up, and some of the things we've embarked on is trying to use a way of knowing what is the problem of farmers. And this was done through structural questionnaires by distributing some of these structured questionnaires with farmers in selected areas in Nigeria. We've also conducted semi-interviews with agricultural experts and extension workers. And several of our members, of our team members, have also been to the farm to make observation and see some of these problems which farmers face. And one major thing that came out of some of this field work is the way farmers have been preventing pests on their farm, on cultivated farm. One of the major pests which disrupt farmers is the rice farmers. And this is quilla birds. As you can see in the image, these quilla birds are a major destruction to cereal crops on the farm. And major ways of farmers tackling this problem is because they know the kind of bird which they are, they most of the time shout, run after them, or use catapults, that's what it's been called in this part of the country, to chase some of those birds away. Their eyes are the sensors that sees this pest and they take actions. So in developing a smart system, the team looked at gathering data sets of these images of these birds as region image of interest, and other data were also gathered, like the field, to see how features could be extracted, and such features include air-like features, local binary pattern, and histogram of gradient. The system was now trained on classifier SVM, support vector machine, to learn from this feature. We're able to develop a system that will be able to detect when some of these birds are on the farm and action is being taken. Some of the action is using reflective light, auditory activating signals, and controlling the position of drones on the farm to chase the bird away. And some of the results we got from—
You have 3 minutes.
All right. Some of the results we got from this is, which it shows that after a while, this bird gets to some of this scaring system. And if we look here, we deploy this system on a live drone to see what is the performance like. Presently, the research is looking at using reinforcement learning to learn from the environment by generating 3D models on the farm and using it to train several network architecture. We're also developing low-cost and energy-efficient unmanned area vehicles so that some of these could be deployed in real time, in real life to farmers. For development of data storage we've started looking at getting data for cassava. Some of our students have gone into the field to gather enough data to be able to train some algorithms. And these data are mapped with the time of the day, location, weather condition, and we are analyzing this. We are analyzing this data to look at pattern. Finally, we are developing mobile application to see what is their performance, and we intend to develop it in the three major Nigerian languages, which is the Hausa, the Yoruba, and the Igbo, so that some of these farmers will get themselves used to it. We're also liaising, finally, we are liaising with local farmers and to see how this, some of our products will help farmers improve their productivity. Thank you for listening.
Thank you very much. That was brief and to the point. Now it's time for 2 quick questions for both participants, Beston, yeah, and Segun. Are there any questions to them? Okay. Okay. All right. Thank you. Okay. It seems there are no questions, and then we can, Martin, you can proceed with the next session.
Okay, thank you, Dina. So this afternoon we have a privilege to have a panel discussion.
No question.
For agriculture.
Okay.
Yeah, so we have a panel discussion, AI for agriculture, food production and biodiversity, on which we have Shira, Dina, Ernest, and Jason. So let's welcome them to start their discussion. Over to you guys.
So I'm on the phone with Dina and Shira. We are discussing. So we'll be back. We'll come back to you guys.
Okay.
After 30 minutes after the session. What did you want us to discuss here in the Okay, so I guess, do you have any leading questions, or does the group have some questions that we could start on, or how do you want to do it, Martin?
I thought you guys would.
Or just discuss?
Yeah, okay. Maybe we could just hear why you guys got the interest in working in this area, and then we can have follow-up questions.
Yeah, I think we can just take around, starting with maybe Ernest, your experiences in all your projects, a brief recap, what you did. Dina, myself, I believe Jason is also supposed to be on this, who is a research intern at DCUT. We can share our experiences and then interact with the participants, especially those who've just presented, because they seem to also be on this journey of applying AI in agriculture and such applications? Honestly, because I think you have a lot of experience, maybe you can start us off with your nuggets of wisdom.
Okay, thanks. Yeah, so one is about Nyeri. Yeah, good times in Nyeri. Okay, thanks a lot. Thanks a lot, Shira. Yeah, so this, I guess, an interesting topic, this idea of agriculture, production and biodiversity. And maybe just, I guess, historically, I think there's been change in sort of the agro process, I imagine. So we are seeing, I guess, like from the last presentation, there was talk of growing need for food and growth in population. And so this idea of intensification, I guess there are two things here. One is sort of intensification of agriculture, where you're sort of trying to maximize the production per unit piece of land cultivated. And then there is biodiversity. And I think there is some sort of fight between these two, or at least as we try to intensify agriculture, there seems to be some degradation of biodiversity. But maybe I'll just talk about agriculture, since that's what I've been on. Yeah, that's what I have knowledge, experience with. And I suppose this intensification, they are probably going back to those axes we discussed. So identifying things around among experts, so the labor required to do intensification. And then the other thing to do with methods. So intensification, I guess, had this prescription, or it has had this prescription that previously, when the land got infertile, or this area was not producing crops, then you moved to another piece of land. People just migrated to another piece of land that was more fertile, or had where it was raining, and then they started growing their crops. There was really no need for intensification, or to think about how can we improve productivity per unit piece of land. But as I guess population rise and land gets scarce, there was need to think about these types of things. And so maybe in this era of AI and data science, be good to think about those two aspects. I'll just talk really briefly. One on the improving on processes on a farm. And we know there's a lot of data that you can collect on a farm. And I think a lot of the examples we've seen have been things to utilize this data. So you could collect image data. So you could collect images of your plant every day, for example. And if you had the capacity to do that, then you could see how you could potentially use all that data to make improvements on your farm or your garden. And so, but there's lots of data. There's soil data, soil conditions of your land, water usage, there's weather data. And so there are all these ways we can try and use things like data science and AI to optimize these resources we have to produce a better yield. And this has been a component of intensification, and something that many people here have been trying to do. And then there's the other thing of trying to do weeding or improve how you control pests and diseases that come onto your farm. So these are external to your farm, but they could come to your farm. How do you get good materials to plant? So I guess that's one aspect. The second aspect is to do with labor. So how do you, so I guess there's been big migrations of people leaving gardens and going to town, going to cities. And I think one example is the previous presentation where using drones. So instead of people doing actual survey work, you can use drones to give you an idea of how your farm is doing. But you can also think sort of broadly about things like agricultural bots. If you have big farms and you have a robot, an agricultural robot that can sort of go around, do weeding, never gets tired, it's sort of more accurate, it can be fine-grained, it can do things per plant, you know, it's faster. So these are things where you can sort of deal with the labor challenge that's related to agriculture. And of course, even the discussion on chatbots, again, you could sort of think of using chatbots for farmers, give them advice to optimize the way they use their limited resources on land to produce more. So I guess this would be I guess what I've talked about is sort of ways, some of the ways that we could think of AI and data science affecting production. Thanks.
Yeah, cool. I think I would like Dina to give some of her experiences, especially in data collection. We saw you in the farm, in the chicken farm, and how much data do you actually need? So, in other words, maybe your experiences in collection of data and how much effort is really needed to get data sufficient to train these AI algorithms. And then, yeah, maybe tell us a little bit about that.
Yeah, thank you, Shira. And I thank you, the other panelists, Ernest, for sharing his experience. And the experience for data collection, as a data scientist, you know, when you have the problem already framed, you want to straight away have the data in front of you and start training. So when the data is not available and the data collection task takes time, actually it's time consuming. That's what I really, the reality on the ground. And also setting the mechanism is a collective effort. So you really, the mobilization until you start the actual collection, the actual data collection as well is takes time. And normally the funding constraint, the budget actually also sets the path of how you're going to approach. If you don't have enough funding, it's even a challenge to involve the stakeholders at the national level in the agriculture center. So when it comes to, we are guided by the deep learning guidelines that you really are aiming for a data set of not less than 1,000 samples per class. That's really what you really see is enough. But there are also algorithms that can be trained with data less than that. Transfer learning is really helping that, but you really want to have a baseline model, at least reaching that of having at least 1,000 images, not less than 1,000 images per class. But again, the realities on the ground and the budget constraints guide have to be compromised, have to also be taken into account. And also, since the work is interdisciplinary when it comes to data collection, the stakeholders, their engagement early on onto the project is important. And another challenge that we really face when it comes to data collection is setting forth expectations, high expectation to these stakeholders, that you are collecting the data so that you can create, you are going to develop a tool that is going to help them detect diseases early before they bring much damage on their farm. So once you have collected the data, that time lag for you to go back and actually test the tools with them, it really puts much pressure on you as a developer. They really expect like, okay, they've collected the data to make their tool, so they really expect you like the following week or the following month to be back and you'll be testing the tools at their farms. So that striking that balance is also a challenge. So what we did, we have 3 regions that we expect to cover in the scope of this project. So we have said that we're collecting data from 2 regions, and the Manyara region, which is a bit far from Arusha, will use that mainly for testing once the tool is ready. So at least we've not set expectation to farmers in Manyara, and also like the rest of the farmers in Kilimanjaro and Arusha. We really have to do our best to maintain to maintain them. And again, that's really brings the open problem we had. I had mentioned earlier about how do we incentivize these farmers to stay on board, and when you take the tool to their farms, and also being able to recruit new ones, and eventually be able to crowdsource sending forth the new data. Yeah, so setting expectation to farmers and incentivizing them is quite an open problem that we really have when it comes to data collection. Yeah, thanks.
Oh, great. So maybe we can hear from Jason. I know you've been involved in deploying IoT systems in various ecosystems, especially in Kenya. I know you'll be giving a talk tomorrow on water system monitoring. Maybe you can bring your perspective as a student in actually deploying systems to collect data. And then after that, we can open the floor for questions and interaction from the crowd, from the rest of the audience. Over to you, Jason.
Okay, thank you. Thank you, Dr. Shira. I'm Jason Kafi from Center for Data Science and AI at Kimathi University. In the last couple of days, we had had the privilege of listening to very interesting talks, mostly in agriculture, the disease classification of diseases and all that. Mostly I've been involved, like Shira said, I'm giving a talk on monitoring the water levels of a specific area, in a river specific area. So my experience as a student and also as a data scientist in the deployment of IoT systems, I may say, I think the best advice I got from Dr. Shira working under Unmanned Center for Data Science and AI at Kimathi is that when it comes to deployment of IoT systems, you never know the problem that you are going to face until you deploy it. So when it comes to me, deploying the systems, according to me, is that you must first deploy, maybe even if it's a prototype one, so that you may know what problems to face in deploying and how to tackle those problems, that you at the end of the day, you can sit down and come up with ways of tackling the problems that you are going to face. Also, when it comes to deployment of IoT systems, at this point, my early stages is that we are not very sophisticated in that. Also, we don't have the manpower. So at the early stages, you have to do everything by yourself. So maybe as time progresses, there is division of labor. There is people who tackle the network issues. There are people who concentrate on the hardware deployment, hardware manufacturing in this case. There are people who concentrate on the software development and all, but it is good as a data scientist and a researcher that you are conversant with every every section of the deployment, in that you're conversant with what is to be deployed in terms of hardware. You're conversant with how the hardware is working, that is the software that is also being used to run being used to collect the data in this case. And also you are conversant with how to process the data, that is machine learning and AI and all that. Also, I've come to understand that deployment of IoT system, it takes a lot of time, because it takes time so that you can be very so that you can get everything right. So it takes a bit of time there, because on Saturday, that is the workshop, I think the second workshop day, I'll be giving a talk on deployment of water level monitoring systems. That is at All Projecta Conservancy. It is located in Kenya at River Wasonyero, which runs through the conservancy. It is a lifeline to the wildlife there, and also to a lifeline to the communities there. I'll give you an example that the first prototype I deployed there, I didn't take into consideration everything that was there. So I deployed the prototype and it did last a week. The baboons descended on it and it did last a week. So it gives me an insight of what to expect when deploying the next prototype. So that was what I was saying, in that you must deploy for you to know the problems that you are going to face in the field and in data collection. For the rest of materials, I think I will talk about is during my slot on Saturday. Thank you, Shira.
Thank you very much. I think there's a question from John to the panel. I hope you can all hear me. Maybe John, you'd like to just unmute yourself and ask it. And anybody else in the audience, maybe just raise your hand and you can interact with the panel.
Sure, thank you, Shira. So yeah, I'm interested in if anyone has had any surprising experiences where things didn't work. I think we've heard lots of interesting talks about what people are trying, and many of these things have been successful, and that's great. I always think we can learn a lot from what doesn't work as well. So my question to the panel is, did you try anything in AI in agriculture or data science where you thought something was going to work and then the technology ended up being inappropriate? Thank you.
Yeah, so I have I have maybe examples from actual application and examples from, I guess, building the models. So from the applied side, so we did this work, and I think parts of it are still being done. The idea was to detect or to determine the extent of necrosis, of rot on the cross section of a cassava tuber. So a cassava tuber is cut, and then you use, ordinarily what they do now is that someone looks at it and determines a proportion of the cross section of the root that is damaged and writes it on a paper and moves on. So I guess the way we did it is collect images, of course, and then train a segmentation model for this. And it sort of seemed to be working, we got it to work in the lab. We even put it on a mobile phone, got it to work, and then we went out to the field for a trial. And so the shocking thing in the trial was, the trial had an expert, someone who's digging out the root and cutting it, an expert who scores on a paper form, and then we had someone from the lab with the app taking an image and having it scored. But what shocked us was that, so while it works really well in the lab, in the field it also works, but the problem is that it just takes too long. It takes too long. I think it took So you take an image, it took maybe, I don't know, maybe 5 seconds or 4 seconds. And this was too long. It was just too long for the experts. So the experts look at several cross sections, maybe 5 of them at one go. And then from that, it determines a number that sort of averages or a number per route and moves on. So it's very quick for them. So when we had a technology that took an image and sort of delayed, took a couple of seconds, it became untenable for the experts. Yeah, I don't know what that is. Okay, so that was one technology that didn't work. So worked in the field, worked in the lab, works in testing, but fails to work very well in the field. Other things were, I was involved in a project where we're measuring certain aspects of yield, like the length of a route or the weight. And there was no way to do this. The only way to do this was to put the route on a green background and take an image, and then, but this just didn't work in the field. So works really well. You can describe an experiment where you actually calculate the height of a root tuber, but the length, but you really can't do it in the field. So those are 2 examples, at least in the field. I'll let other people give examples.
Dina?
Yeah, thanks, everyone. For us, we're still mainly on the data collection phase, still starting on the training. And the fact that you really want to record every sample that you are collecting to be able to, you capture the image and using the ODK and then the sample on the zip bag. So for the extension officers who are collecting the data, it was quite a challenge for them to see the importance of capturing that image using the phone camera. They really concentrated on getting the samples on the zip bag. So it was quite a challenge to introduce the ODK to the field officers and the vet to adopt it. And I was like, this is where really the solution we expect to develop from. So we really have to capture the digital data carefully. So the fact that we focus on early detection, so we also challenged to address whether, to what extent, like in one farm, that the farmer will capture images and then say, this particular disease is here. So that's where we really see what we really have to do later. And then, although we have collected over 1,600 images in the 4 classes, the initial results in the lab are discouraging, but we hope to improve it so that we are able to go back to the field to do the testing. So that's how I really see technology. We got the ODK designed very well in the lab, tested every question. And when we went to the farm and we found it irritating to the rest of the data collectors, we had to go back, reduce the questions. Actually, we broke down to two ODK forms so that we reduced the questions so that it becomes like very short. So we had to really reduce the form to a maximum of 4 questions and be able to get the data collected. So really, things work in the lab, you test everything, but when you go to the field and the realities, people became really restless, impatient in collecting that data using that particular form. We had to review everything, yeah, and make it as short as possible. Yeah.
Great.
Yeah, that's
before, maybe we can hear from Segun and Beston, who also talked in that session. What major challenges you faced? Okay. Are they? Yes, I see Segun. Go
Okay.
ahead.
One major thing we faced as I think one of the panelists talked about is trying to get some data from the field. Some farmers, I think one of the panelists, when she was saying that there's a need for incentives. In this part of in Nigeria, maybe because of the poverty level, they need an incentive before you take data from their farm. And it's a major challenge because despite the fact you explained that some of these products, when they are being developed, will be tested, on their farm to improve their livelihood, they still probably need you to give them something in terms of money, not waiting till when the product is being developed. So it's a major thing trying to, get money from you in trying when you are trying to collect data. So it has been a major thing when we're trying to get some of this data from the field. Thank you.
Okay, seeing that we are almost out of time for Martin, you can tell us how much more time we have. Maybe Jason, you can also share some of your experiences, what things haven't worked and what has been most challenging so far in your journey as a student here in trying to deploy systems. As we wait, okay. And anyone else who has any question on the chat can quickly get it before we get kicked out by Martin.
Okay, thank you, Shiro. On my part, the thing that have been a challenge is mainly, I'll start with the powering of the system. At some point, I think I was a little bit overconfident with the whole power issue, in that during the day, because my system is battery powered and I have a solar panel to charge the whole system, to charge the battery. I was confident with the size of the solar panel and also the size of the battery. So I ended up the time series data I'm receiving during the day is quite nice, but the night data is garbage. So that is a problem because of the overconfidence on that. So that is a problem currently I'm trying to correct, so that I can correct, or so that I can have a system that will work during the day and also during the night. It's not like we have a system that can only work during the day because of the sun is out. So I have to correct that. Also, another problem I faced, because I said I was deploying my system at a conservancy, so there were wildlife there. I told you my first system or the first prototype, that is, it got destroyed by baboons at the conservancy. That was quite a shocker. So to solve that, I decided to create a cage. I think engineer showed us one of his prototype with a cage around it to protect it. So that is what I did also. I did mine, and I'm pleased to announce it worked, because I've been correcting data now for around 3.5 months. So it's quite nice to be correcting data from it for quite a long time now. So, but the main issue was on the power, because of the night data. So that is an issue I'm correcting. I'm still correcting. Thank you.
Okay, so there's a question to the panel about identifying where you can purchase appropriate IoT devices, I think for use in agriculture. I believe one of the presenters talked about IoT deployment in a poultry farm. Maybe they can share some of their experiences, but also engineer, maybe you can tell us how best to build IoT systems for deployment in agriculture. Give us your thoughts on that. And together with, I believe, the previous presenter who talked about the chicken.
Sheila, sorry, I didn't get the question quite well. If you could repeat, please. Thank you.
Oh, sorry. I was asking whether you have any thoughts about where people can purchase or how best to develop these IoT systems that are robust for deployment in agricultural situations.
Okay, thank you. I think as Jason was just saying, you need to adopt an agile approach. As you build the IoT system, I think you need to get it out quickly and deploy it in the context that you are targeting, and then as you do that, you learn and improve. So I think the answer to that is deploy quickly and improve rapidly. I think that's what I've learned over time, and the challenges that I think we've experienced in deploying systems. Some of them are obviously common to other projects, but they are also specific unique challenges that you actually know when you deploy. For instance, putting a monitoring device on a border, we assume that the motorbikes will always have battery, and the first assumption was that we could get this powered by the batteries from the motorbike, but actually in practice, we found that the border riders don't replace their batteries when they fail, and just because they are able to kickstart their motorbikes without the self starter. So when the batteries, most of the borders don't actually have a functional batteries, but you don't get to know these issues until you actually deploy. So the first assumption that we had was invalidated, and we had to think about how do you now actually get the unit powered up without the working battery. In agriculture, I think it's the same challenges. I think when we deployed one of the devices, I did a small project on soil moisture monitoring, and it was the same issue. Like we had this idea that we could actually monitor soil moisture conditions and inform the planting decisions. But soon after taking this to the farm, the farmers told us, you cannot just assume that you can get the water requirements for, let's say, maize or cassava alone, because for us in our field, we grow cassava, we grow maize, we grow sweet potatoes. So you have to think about intercropping. So you can't assume that your gadget can give us information on cassava alone, and that will actually serve the purpose. In terms of component selection, again, this comes with our experience, as I mentioned earlier on. Once you identify the components, obviously you need to do a bit of some research and evaluation and see, have the sensor components been evaluated? What's the performance? And there are quite a number of platforms online that you can actually check out and do trial evaluation before bulk purchases. But also at least for the start, you have to improvise and look around in the local markets. You'd be surprised if you go around the local shops, electronic shops. For some reason, they have some of these electronics, but for different purposes. So some of those can get you started without necessarily having to import some of the components. I will stop there. Thank you.
Okay,
Hello.
thanks,
Hello.
engineer. I think I have to stop the panel now. I know
contribution.
we have two interesting discussions, but I think we need to go to the next presenter. So let me introduce the next presenter, who is going to be presenting to us deploying species identification models on camera traps and web application for automatic monitoring of animal species in a conservation area. So welcome, Jad Macario. Do we have Jad online?
Yeah, sure. Hello.
Hello.
Can you hear me?
Yes, you can share your screen now.
Okay, thank you.
So you have 20 minutes.
All right. Thank you. Please let me know when you see the slides.
Yes, we can see them clearly now.
Thank you. Well, my name is Jared Macario. I'm currently a research intern at Center for Data Science and Artificial Intelligence, DSAIL, which is in Dedan Kimathi University, and led by Dr. Shira Omaina. At the center, we do a variety of projects ranging from data science, IoT, to artificial intelligence. So I'm humbled today and happy to be here and presenting a piece of work that we have been working on deploying species identification models on camera traps and web application for automatic monitoring of animal species in conservation areas. Ethically, we have been given the permission to conduct our research at Ol Pejeta Wildlife Conservancy. It's one of the conservancies. It's one of the conservancies in Kenya, specifically in Nanyuki. For those of you who don't know where Nanyuki is, maybe you can check the map of Kenya. So Africa is home to over 400 known wildlife animal species, and they constantly face threats from various actors such as poachers, natural calamities, including bushfire and floods. So in figure 1, you can see one of the 281 elephant carcasses reported by the Botswana government early this month. It is one of the death tolls of elephant species in Botswana around Okavango Delta. And also in figure 2, you can see a fire outbreak in Tsavo National Park in Kenya. It was a few weeks ago. So wildlife is under a threat. Monitoring them is one of the key steps towards conserving them. And historically, there have been various methods of monitoring these animals, camera traps being one of them. But can you hear some echo? No. Oh, thank you. Okay. So Camera traps is one of the methods of monitoring these wild animals, and whereby camera traps are deployed at various locations in wildlife conservation points, and where they collect images which can be later be analyzed. However, the camera trap data collection process is manual, expensive, and time consuming, as pointed out by Dina and engineer Baino. So one of the studies done by the Snapshot Serengeti project shows that 76% of the data collected is labeled empty, and this is one of the areas whereby we need to ask ourselves which methods we can use to analyze this image data. Also, as we go by, various studies are coming up, deploying more camera traps, and in the process, they generate thousands and millions of camera trap imagery. So we need tools and applications to analyze these big data before they pile up and kinda expire. So lucky enough, there have been progress in deep learning methods, specifically in transfer learning, whereby there is great use of state-of-art pre-trained models, and also the existence of open source datasets such as Snapshot Serengeti, and some data that we have obtained from Old Pejeta Conservancy. And also, these images and these data can be analyzed using application tools such as applications, whereby we are developing one application as shown in figure 3, whereby that project is from the preliminary work, and also the use of the camera traps themselves, which is one of the non-invasive methods that you can use to monitor these wild animals. And also we can use Raspberry Pi, the new models such as Raspberry Pi 4B, whereby we can leverage its computing power to explore and leverage the ML on the edge. So our main objectives we are focusing on is identifying the animal species on these camera trap images, and also trying to get the count, the number on the images, and their activities, the way they're interacting with the ecosystem, and try to relate the camera site IDs to show the location of these animals. So also we are intending to process the images close to the source, that is in the field on the edge, to just send the inference to the cloud where the application is hosted to visualize the data. And also the application that we have been developing, it's aiming at analyzing and labeled data sets, and also getting up a kind of a pipeline to help analyze this data. So on the left, you can see figure 4. That's one of the images that was taken at the Old Pejeta Conservancy. So that's the nature of images that we are dealing with. The existing method or what has been what is existing is that we have state-of-art pre-trained models such as ResNet 50, VGG16, and Inception, models whereby someone can get them off the shelf and use them to classify general objects, And the existence of the open source image datasets such as ImageNet. Also, we have the common object in context, COCO dataset, and iNaturalist. So these datasets, one can use them to train a model from scratch. However, training these models from scratch, they might be less accurate, and some of them need large data sets. And bear in mind that some of these state-of-art pre-trained models classify up to 1,000 object classes. So they can be any object like a desk, a chair, and our task here is to identify animal species. So those are the existing method. As explained earlier in this work DSA summer school by Mr. Ernest and Benjamin, we are using transfer learning. So it's a great experience to improve the accuracy of pre-trained models. The strategy we used, since the data that we were dealing with is imbalanced, we used this size similarity matrix to determine the type of transfer line that we are to use. So we avoided quadrant 1 and 2 because we had little data, so we could easily fit to quadrant 3 and 4. And also we dropped quadrant 3 because yes, we had small data set, but it is kind of similar to the pre-trained the ImageNet. So we used quadrant 4, whereby we have small data set similar to the pre-trained, the one that is used to train the pre-trained model. So we decided to use we did the freezing of the convolutional base and removed or popped out the topmost layers and trained our own classifier to classify the wild animals on the images. So the nature of the data set we were using, there were two. That's the snapshot Serengeti data set that we used to fine tune VGG16 and ResNet 50 pre-trained models, whereby we had to choose the best out of the two. Also, there is all Pageta sample data images that we are using to test the fine-tuned model. So in total, there in snapshot Serengeti dataset, there are 53,499 JPG images, and as I said, the data is imbalanced and having 60 classes. So we saw that the imbalanced nature of the data gave us an idea that we have a lot of images to certain species such as wild beast and less image data to other species such as bats. So we went ahead to use the top 10 most frequent species that were well pronounced and well distributed in the area. So we used the area that Snapshot Serengeti project did their work, that is in Serengeti National Park in Tanzania. So to get up and running, we identified two models that pre-trained models that we were going to fine tune, that is the VGG16 and ResNet 50. And then of these top 10 frequent species, each species we used 70% training data and 30% validation, whereby this 70% was 1,500 images in each species in train, and 500 images in validation in each species. So using other techniques such as data augmentation, as explained by Mr. Ernest, we used all data set to fine-tune the pre-trained model, and developed a web application which was developed using Python language, dash Plotly, which uses Flask as a framework under the hood, and tools and libraries such as TensorFlow and Keras to have a model on the dash application to do the functionalities of classification of these wild animals on images. So that is a sneak peek into the application that we have been developing in our preliminary work, showing the classifications on the left, and also on the right there is an image showing the application, showing the location of a specific species in Serengeti National Park. So what's next? In our future work, we are intending to scale out to identify more species, since we are currently doing 10 species. So we want to scale more to the 60 species, and also deploy the models on camera traps, real camera traps, and assemble the camera traps using the Raspberry Pi cameras, the motion sensors, and deploy them at Old Pajeta Conservancy. And also we intend to benchmark on other models so that we find which model is the best to kinda use in our application. So the architecture that we are trying to achieve at the end of the day is here. So we have, for example, a Raspberry Pi. We have a Raspberry Pi deployed in the field, whereby when a motion is detected, the camera takes an image, processes on the edge. If the image is empty, it's deleted. If it has some animal species, it is stored in the SD card. The inference is sent to the LoRa gateway, and this gateway is put in the in a middle station in the conservancy, and connected to the internet and power. And also from now the gateway, you say the inference is sent to LoRa network server, whereby later the data is channeled to our front-facing application where we can visualize that. So we are employing deep learning method, fine-tuning the pre-trained model, deploying the fine-tuned model, and leveraging some IoT network that we have, such as LoRa, to transmit some inference. When the SD card is full, someone can visit the field and exchange the SD card to store more data.
Excuse me, I think I have to stop you. I don't know whether you can summarize.
Okay. So what you can see there is the Raspberry Pi 4. They come in they come in specs of 2 GB RAM, 4 GB RAM, and 8 GB RAM. We can leverage computation at the edge. Yeah, thank you.
Thanks very much for a wonderful presentation. I'll allow 2 questions. before we have the next presenter, but people are encouraged to send their questions in the question and answer part, such that we can, continue with other presentations. Those who have questions, you can put up your hands, and then we allow you to talk, to ask the question.
Yeah, sure. I'm here waiting for the questions.
Maybe there are no questions, so things were clear. I don't know.
Okay, so maybe to summarize what you're seeing there, that's the application. So I was expecting to do a demo, but because of time, maybe we'll do it some other time. Thank you.
Okay, thanks very much. So our next presentation is from AfricaPolis. So I don't know whether we have.
Hello, this is Abel speaking. I'm happy to start the presentation if you give me the right to share my screen.
Yeah, let me do that. I think it's, yeah, you can now share.
Perfect. Can you see my screen?
Yes, I can. We can.
Perfect, excellent. Thank you so much. My name is Abel Schumann. I'm an economist at the Sahel and West Africa Club, and I would like to use this opportunity to present the AfricaPolis database of urban areas to you. But before I start my presentation, I would first of all like to thank the organizers for inviting us. I think you have put together a great program, and it's really a pleasure to be here today and to be part of this this great workshop. Now, what is the AfricaPolis database? In a nutshell, it's a database of city populations going back to 1950 and ranging until 2015. And for those of you who are not familiar with policy, you might wonder, first of all, why is it important? And secondly, why is it difficult to create a database of city populations? Now, starting with perhaps the little easier question, why is it important to have a database of agglomerations? I think you all know, even if you're not working on urban policy, that urbanization in Africa has been progressing extremely quickly in recent decades.
It seems you get lost and then you come back. Maybe you need to get close to your mic.
Excuse me, is it better like this?
Yeah, I think it's better. Yeah, like that.
Okay, apologies. Please interrupt me if you can't understand me. Okay, so first of all, why is it important to have a database on urban agglomerations? Now, we all know that Africa has been urbanizing very quickly in recent decades, but what is perhaps less known is that this urban transformation has not been uniform across the continent, but that has been very multifaceted and has been a very multidimensional process. And to understand this process, and more importantly, to actually develop good policies for urban areas, we actually need to know what is going on. We need to have data on urban areas. And now the more important question even perhaps is, why is it difficult to produce a database of urban areas across Africa?
Oh, we're losing again.
I'm really sorry. I don't know whether it's my connection or does it help if I speak more loudly?
No, somehow you get lost and then you come back. I don't know.
Are you moving?
I can hear you very well. I don't know what's the issue. Normally my audio should work fine. Can you hear me?
Yeah, we can now.
No, okay. I don't know. I'm really sorry for this. Please let me know again if you don't understand me. So coming back to the issue, what are the challenges of creating a database of city populations, of urban agglomerations across Africa? There are two main issues that we face. First of all, when we look at national definitions of what is urban in Africa, we see that these definitions actually vary a lot from country to country. So we have, for example, 25 African countries that have a purely administrative definition of urban areas. So a city is considered everything that is an administrative center, is the seat of a local government, has a particular administrative unit in place, and that is, for example, the case in Chad. Then we have 12 other countries across Africa that actually use a mix of administrative and functional definitions. So you can have, for example, situations such as in Cameroon, which defines cities as administrative centers that have either more than 5,000 inhabitants or have sufficient socioeconomic and administrative infrastructure to count as a city. And then we have a few countries such as Ethiopia, which define cities purely by its population size. So in Ethiopia, for example, every locality with more than 2,000 inhabitants is considered to be urban. And here, different countries use different thresholds. We have some countries that go all the way down to 1,500 inhabitants. So everything with every locality with more than 1,500 inhabitants is considered to be urban, whereas other countries go as high as 30,000 inhabitants. So in other countries, the locality needs at least 30,000 inhabitants to be considered urban. And then we have 3 countries which use a mix of a numerical and functional definition. And already from this variety of definitions of what is actually considered urban, we understand quickly that it's not possible to use these national definitions to compare urban areas across countries, because in the end we would actually compare apples with oranges. So we would compare very different places with each other if we just look at the national definitions. But then there's actually a second issue that we face. That is the issue that usually the statistics that are created from official data, usually from census data. That census data applies to official administrative boundaries. And these
Your voice
I don't know. I'm not sure. I don't know what I can do. I have my microphone in front of me.
I think just be close to your mic maybe, and we try and see.
Okay, I try. So a second issue that we are usually facing is that the administrative boundaries that are used to produce data for the census, they don't correspond to the realities of the people. So what we see here on the screen is a map actually of Maputo in Mozambique, where we see in red the built-up area. So that is what people would normally consider the city of Maputo. And then shaded in blue, we see what is considered to be the official administrative area of the city of Maputo. And we see that the red area, the built-up area of Maputo, so the area that people would normally consider to be part of the city, actually goes well beyond the administrative boundaries of the city of Maputo. And since the census data is produced for the administrative boundaries, it's no surprise that in the official census data, the population of Maputo is much lower than what we think is the actual population of Maputo. So according to the census, roughly 1.1 million people live in Maputo, whereas we think the true number is actually closer to 2.6 million. So you see, these are not just nuances; these are really fundamental differences. Here I give you another example. What we see here is the development of the share of the urban population in Egypt among the total population. And what we see here, that according to the official definition of Egypt, for the last 50 years approximately, the share of the urban population in Egypt has been slightly below 45%. And I just would like you to keep this slide in mind, because I'm coming back to it later. But just remember that according to the official definition, Egypt is roughly 45% urbanized. Now, when I say I don't believe that official definitions of areas are the most meaningful way to compare cities across different countries with each other, what do we think is a better definition? We think a definition that is based on built-up areas and based on a population threshold is more meaningful to compare different cities and different countries with each other. So we have developed a definition for AfricaPolis that is relatively simple. We define contiguously built-up areas as places that have buildings within less than 200 meters of each other, and if those contiguously built-up areas have more than 10,000 inhabitants, we consider those places as a city. So we have essentially two definitions. So first of all, buildings need to be closer than 200 meters from each other in order to be like a single unit, a single contiguously built-up area. And secondly, in order to be considered a city, this contiguously built-up area must have more than 1,000 inhabitants. 10,000 inhabitants. And now, once we have a definition, we can actually apply it across different countries, essentially across the entire continent. So how do we do this? First of all, we use satellite imagery to derive built-up area. This is being done through image manipulation. So that's primarily contrast enhancement, which allows us to identify the areas that are built up. And once we have identified the built-up area, we combine the information on the built-up area with census data. So we use information, for example, from census districts to estimate the population number of this built-up area, and then we come to data for what we consider as a city, which is a contiguously built-up area that is independent of administrative boundaries, and we can determine the population of those. Now, if we do this for all of Africa, we actually come up with this picture. So we see that in 2015, we have identified 7,617 urban agglomerations across Africa. And on top of that, we have data.
We're losing you.
I'm really sorry again. I try my best. I have the microphone directly in front of my mouth. Should I repeat?
Yes.
Yes. So we have this. So if we apply this method to all of Africa, we come up with a comprehensive geospatial database of agglomerations across Africa. We have identified 7,617 urban agglomerations in 2015, but we can also actually use the method to go back in time, and we do this until 1950, and that allows us to describe urbanization dynamics throughout Africa over the last 65 years. And of course, once we have the database, we can actually look at how what is the state of urbanization across Africa. And what we see here is that we have, for example, 25 cities with more than 3 million inhabitants, and taken together, there are 146 million people living in those 25 large cities. So we have 3 million cities with more than, we have 25 cities with more than 3 million inhabitants, and taken together, they account for 146 million people. We also have 49 cities with between 1 and 3 million inhabitants that are home again to 82 million people, 148 cities with between 300,000 and 1 million people, 485 agglomerations with between 100,000 and 300,000 inhabitants that are also home to 80 million people. Then almost 2,000 agglomerations, 2,000 cities with between 30,000 and 100,000 inhabitants. And last but not least, we have almost 5,000 cities that have between 10 and 30,000 inhabitants. And they are also home to 84 million people. And I think that's actually an important realization, because when we look at the data, we see that there are actually more people living in these kind of small towns and small cities than there are people living in very large cities with between 1 and 3 million inhabitants. So often when we think about urbanization, we think about these very large places, but it's equally important to think about small and mid-sized cities because they are so common and so numerous that they are home to a large number of people. And of course, since we have the data going back in to 1950, we can actually also look at it to determine the pace of urbanization. And for example, when we look at this map and look at our virtual host country, Uganda, we see that the population in Uganda between 1950 and 2015 has grown by more than 8% annually. And that's actually a huge number. If you have an 8% growth rate over a 65-year period, that actually means the urban population in Uganda has multiplied by a factor of more than 200 over the last 65 years. So this has been really a tremendous urban growth. And now, actually, when we look at those maps here, we see the share of the urban population among the national population. And I would just point your attention to the map of 2015 and to the country in the northeast of Africa, to Egypt, because when we look at this map now, we see that more than 80% of Egypt is urbanized according to our definition. And now, when we think back to the chart that I showed you earlier, where Egypt, according to official statistics, had an urbanization rate of 42%, we see actually that it makes a huge difference how you define urban. So if we just look at the official statistics of Egypt, we actually would have thought that there's no urbanization going on over the last 50 years. But what we think is the much more realistic picture is actually that the share of the urban population has actually doubled over the last 50 years. So there are huge differences, and that actually shows the importance of using a comparable and uniform definitions when we want to talk about urbanization across countries and make these kind of comparisons. Now you can actually use the data for many more things than just looking at the evolution over time. We can actually look at the emergence of new agglomerations, of new cities. We see that between 2000 and 2015, almost 2,500 new cities have emerged across Africa. So there's a huge number of new cities. Now, when we think about how urbanization takes place, we might have this picture in mind that
is asking, how do you estimate the population in each city?
So that's a good question. So that is being done by using the lowest level census data that is available. So ideally, census data is available at a higher resolution than the built-up area. So then we simply can aggregate the census blocks for the entire built-up area to come up with an estimate for the city. What is a more complex situation is actually when, let's say, census data is only available for province, and we have 5 different cities within this province. Then we have to make assumptions on the population density of the built-up area to distribute the population of the province to the individual cities that are the individual built-up areas within the province as well as the rural areas.
Okay, thanks. Another question is from Elaine. Is AfricaPolis data available for research?
That's all available. Just actually what you see on the slides now at the bottom, www.africapolis.org. There you find all the data, so you can download the entire data set. You can download the shape files of the extent of the agglomerations, as well as an Excel file with the population data of all agglomerations from 1950 to 2015.
Okay, any other question? So maybe we can.
Thank you again for your attention. It has been a pleasure. Please, there's also an email address on the website. So if you have any more questions, feel free to contact us, and we are happy to get in touch and provide more details or exchange ideas.
Okay, thanks, Abel. But maybe you stay online. People may have more questions after listening to Mike. Yeah, so let me take this opportunity to invite Mike, who is going to present social connectedness between African countries. Mike, are you online?
I'm online. Can you hear me?
Yes, we can.
Fantastic.
Then you can share your presentation.
Great. Can you see my screen?
Yes, we can.
Excellent. So thank you so much to the organizers for inviting me. I'm very excited to be here. I'm really excited by being able to participate today and hopefully participate in several events in this community in the future, and happy to connect to everyone here and meet you all. I can't wait to, really sad I wasn't able to be there in person, and can't wait till the next one where hopefully I can fly out and meet everyone in person. My name's Mike Bailey. I'm a researcher at Facebook, and I've been working with Abel, Inhoy, and Philippe at the OECD on trying to understand social connectivity in Africa. And so the first question is, why do we study social networks? So social networks are the connections we have between friends, between the people we meet, the people we talk with, and they play a fundamental role in our lives. You know, our friends influence what we buy, where we live, how we spend our time. Networks impact trade, information, migration, voting, and they have a huge impact on nations and the shape of nations. And cities where we put people in close proximity to each other lead to a lot of idea sharing, productivity spillovers. Cities create this huge economic engine because of our ability to meet and talk and associate with lots of people. But the big challenge for researchers is, how do we get data on networks? Because we, you know, as researchers, as practitioners, as policymakers, we want to know, can we measure networks? Can we measure where people have friends and where our friends live and how connected are different areas? So at Facebook, we've developed something called the Social Connectedness Index.